Hi students, this is Kumar, your maths teacher, grade 8. So the next properties of square is the third property. Square of even numbers are always even number and the square of odd numbers are always odd numbers. For example, 84. 84 is a even number. So 84 square. So 84 into 84 answer is 7056. So squares of even numbers is always even number. So the next one is 33. So 33 is a odd number. So squares of odd numbers, 33 square is 33 into 33 is 1089. So this also odd number. So the squares of odd numbers are always odd numbers. So the next property is if n is a perfect square, then 2n can never be a perfect square. If n is a perfect square, then 2n can never be a perfect square. So the fifth property is a perfect square number is never negative. A perfect square number is never negative. There are 2n non-perfect square numbers between the squares of the numbers n and n plus 1. There are 2n non-perfect square numbers between the squares of the numbers n and n plus 1. For example is n is equal to 5. So number n is equal to 5. So the n plus 1 is 5 plus 1 is 6. So there are 2n non-perfect square number. So 5, next number is 6. So 2 into n. So 2 into 5. So 2 5 is a 10. So there are 10 non-perfect square numbers between 5 square and 6 square. 5 square is 25, then 6 square is 36. In between, so there are 10 non-perfect square number is there. So the next example is how many natural numbers lie between 9 square and 10 square. 9 square and 10 square. So here take n is equal to 9. 10 is n plus 1. So 9 plus 1 is 10. The formula is there are 2n non-perfect square numbers. So 2 into n. So 2 into 9, 2 9s are 18. So there are 80 natural numbers lie between 9 square and 10 square. So the seventh property is for every natural number n, n plus 1 whole square minus n square is equal to n plus 1 plus n. n plus 1 plus n. n plus 1 the whole square minus n square is equal to n plus 1 plus n. So the difference of the squares of two consecutive natural numbers is equal to their sum. So the difference of the squares of two consecutive natural number is equal to their sum. For example is 14 square. So 14 is n plus 1. So n is 13. So 14 square minus 13 square is equal to 14 plus 13. 14 plus 13. So 14 plus 13 is equal to 27. So 14 square minus 13 square answer is 27. So the next one is 28 square. 28 square minus 27 square. So this is for n plus 1 square minus n square. So the answer is n plus 1 plus n. So 28 plus 27. 28 square minus 27 square is equal to 28 plus 27 is equal to 55. So the next eighth property is all perfect square numbers can be expressed as the sum of successive odd natural numbers starting with 1. All perfect square numbers can be expressed as a sum of successive odd natural numbers starting with 1. So here 1 square. 1 square is 1. 2 square. So starting with 1, 1 plus 3. So odd number. 3 square. 1 plus 3 plus 5. So then 6 square. 1 plus 3 plus 5 plus 7 plus 9 plus 11. So the formula for sum of first n odd natural numbers is n square. So sum of first n odd natural numbers is n square. Next property is we can express the squares of any odd number. We can express the square of any odd number as the sum of two consecutive positive integers. Sum of two consecutive positive integers. For example, so formula is n square. So n is any odd number. So square of any odd number is n square minus 1 divided by 2. N square minus 1 divided by 2 plus n square plus 1 divided by 2. So for example is 11. So 11 square is odd number. So the formula 11 square minus 1 divided by 2 plus 11 square plus 1 divided by 2. So 11 square is 121 minus 1 divided by 2 plus 121 plus 1 divided by 2. So 120 divided by 2 plus 122 divided by 2. So 120 is divisible by 2 is 60. So here 61. 60 plus 61. So 11 square is equal to 60 plus 61. We can express a square of any odd number as a sum of two consecutive positive integers. So the next example is 3 square. So 3 is a odd numbers. So value is 9. We know that 3 square value is 9. We write 4 plus 5. So this is for sum of two consecutive positive integer. So using this formula n square minus 1 divided by 2 plus n square plus 1 divided by 2. So 3 square minus 1 divided by 2 plus 3 square plus 1 divided by 2. 9 plus 1 divided by 2 plus 9 minus 1 divided by 2. So 8 by 2 plus 10 by 2. 4 plus 5. So 3 square we write 4 plus 5 like that. 5 square is 25. So 25 is using this formula 12 plus 13. This is sum of two consecutive positive integers. So the next property is to find the square of a number. To find the square of a number, we may use the identities which we will learn in the later chapters. To find the square of a number, we may use the identities which we will learn in the later chapters. So a plus b the whole square. A plus b the whole square is equal to a square plus b square. A square plus b square plus 2ab. Then a minus b the whole square is equal to a square plus b square minus 2ab. These two identity. For example, so 23 square. We know the 23 square, write directly 23 into 23 is 529. 23 into 23 is a 529. Using this identity, so 23 square we write 20 plus 3. So nearest is 20. So 20 plus 3. So 23 square we write 20 plus 3 the whole square. So take this is for a, this is b. So a plus b the whole square. So the identity is a square plus b square plus 2ab. So here a value is 20. So 20 square a square. B value is 3. B square is 3 square plus 2 into a into b. 20 into 3. So 20 square 20 into 20 is 400 plus 3 square is 9. 3 into 3 is 9 plus 2 into 20 is 40. 40 into 3 is 120. So 400 plus 9 plus 120 is equal to 529. So 23 square is equal to 529. So the next example is 39 square. So 39 square we write 40 minus 1. 40 minus 1 the whole square. So 40 is take a value is 40, then b value is 1. So a minus b the whole square. So the identity is a square plus b square minus 2a into b. So take a value is 40. A square 40 square plus 1 square minus 2a into b. 2a into b. So 40 square 40 into 40 1600 plus 1 square is 1 minus 2 into 40 is 80. So 1600 plus 1 minus 80 is 1521. So 39 square is equal to 1521. So the next property is to find the square of numbers ending with 5. So easily to find the square of numbers ending with 5. For example, 25 square. So the ending with 5. So easily to find. So we know that 25 square is 625. So how to find easily? To 25 square. So 2. So 2 the next number is 3. So 2 into 3. So multiply 2 into 3 hundreds. 2 into 3 hundreds plus 5 square. 5 is a 25. So add 25. So 2 into 3 600 plus 25 625. 15 square. 1. 1 the next number is 2. So 1 into 2 hundreds plus 5 square is 25. So 1 into 2 200 plus 25 so 225. In general a5 the whole square is a5 the whole square is 10 into a plus 5 the whole square. So a into a plus 1, a into a plus 1 hundreds plus 25. So for example 125 the whole square, 125 square. So here 5 square, so 5 square is 25. So 12, the next number is 13, 12 into 13 hundreds. So 12 into 13 is 15,600. So 15,600 plus 25 is 15,625, 15,625. So one more example is 45 square, 45 square. So 4, the next number is 5. So 4 into 5, 4 into 5 hundreds plus 5 5 is a 25. So 4 5 is a 20. So 20 100. So 20 100 is 2000 plus 25. So the answer is 2025. So 45 square is 2025. So the next property is Pythagorean triplets. If a square plus b square is equal to c square, then a, b, c are known as Pythagorean triplets. If a square plus b square is equal to c square, then a, b, c are known as Pythagorean triplets for any natural number m greater than 1. For any natural number m greater than 1, 2m the whole square plus m square minus 1 the whole square is equal to m square plus 1 the whole square. So 2m, m square minus 1, m square plus 1 forms a Pythagorean triplet. So 2m, m square minus 1, m square plus 1 forms a Pythagorean triplets. Now let us see the few examples. Write a Pythagorean triplet whose smallest member is 8. We know that Pythagorean triplet is 2m, m square minus 1, m square plus 1. Now let us take m square minus 1 is equal to 8. So one smallest member is 8. So take m square minus 1 is equal to 8. So m square minus 1 transposing that side plus 1. So m square is equal to 9. So m is equal to 3. So one member is 8. So here m value is 3. So 2m, 2 into m, 2 3s are 6. Then another one number is m square plus 1. So m value is 3, 3 square is 9, 9 plus 1 is 10. So 6, 8 and 10 are Pythagorean triplets. 6, 8, 10 are Pythagorean triplet. But this question is whose smallest member is 8. But here 8 is not a smallest number. 6 is a smallest. So but 8 is not a smallest member. Now let us choose 2m is equal to 8. 2m is equal to 8. So the m is equal to 4. m is equal to 4. So 2m is equal to 8. One member is 8. So another 2 member m square minus 1, the m square plus 1. So m square minus 1, m value is 4, 4 square is 16 minus 1 is equal to 15. So m square plus 1. So 16 plus 17. So the triplets is 8, 15, 17 with 8 as the smallest member. 8 as the smallest member. The next example is write a Pythagorean triplet whose one member. So the last question is smallest member, but this one member is 12. One member is 12. Now let us choose 2m is equal to 12. 2m is equal to 12. So m is equal to 6. m is equal to 6. So another 2 member is m square minus 1, then m square plus 1. Substitute here 6. m value is 6. 6 square minus 1. 6 square is 36. 36 minus 1 is equal to 35. Then m square plus 1. So 36 plus 1 is equal to 37. So therefore the required triplets is 12, 35 and 37.